going to expound upon an idea that I presented a few times in prior videos. This is a small chunk of what I consider to be a suite of ideas that need to be implemented in order to further secure our data. It's not necessarily on the internet, but in organizations with whom you generally communicate via the internet. But it also applies to just organizations who collect our data, and they're obligated under some laws to protect our data. And of course, I've been in the high tech field for a long time, and I've worked for some of them, and I know they're not going this far to protect our data. Anyway, data is generally kept in a database. So I'll just draw that like that. And it's kept in things called rows, which have values, various values in them, like an address that'll have the street number, street name, town, etc., like that. Anyway, so that could be like a customer's address line or row, like that, and other things like social security address they might keep, your sex, race, familial status, name. These things could all be kept in a database like that. And they will assign certain people to manage this database because it's a very large file and it's a system that has basically a software machine that operates on it. It'll have to be searched, so it has to be indexed. So it collects a bunch of other data about it, and there's a bunch of other software to go with it to do that. Anyway, when they assign people to work on this, called database administrators, generally, especially when it's customer data with a PC card or plastic card industry, there's a certain level of security that they have to apply for doing that. For example, as a software engineer, I probably wouldn't get access to that, but they'd have other people who get access. And these people are not necessarily vetted very well, done background checks, but even if they were, once they get access to this database, they will see all of that. So a place like, say, Bank of America or something like that would have maybe 10 people who'd have access to all the data, and they don't see it. And also, they have a lot of customer service representatives who will be sitting at terminals that have access to this through some other software, and they can just have a look. So what I've devised is a means of keeping this data secure, basically. And secure is confidential. That means people who don't need to see it won't see it, and hardly any people need to see your data on the databases. They need to know it's there, like database DBA needs to know it's there, and say a customer service rep needs to access it through the software, and marketing people need to access it in bulk for searches that will help them design products and stuff like that. And also, people who develop the software will get a little bit of access to it. I guess I've had some access here and there. Yeah, they usually use practice data for that. But so what they should do then is rather have this what's called in the clear data is just basically data that you can see it once you get access to the database. It should all be encrypted. The database itself is encrypted once it's written to the file. I draw the file like that. But that just means that somebody has access to the file system can't have a look at it. And once you download it, if you were to write the file data off to a USB or something like that, it'd just be encrypted. You couldn't see it. But once you get it, once the few people have access to the database, they're still going to be able to see it. So it should all be encrypted, basically. Encryption is you take this number, very large number, and you apply some mathematics to it, and you come up with this garbage that nobody can make anything out of, basically. So every single chunk of this data should be further encrypted with some number, and depending on how you pick that number, you can play around with it and make it more secure. So there's a concept called password-based encryption, which means a person will get a password, and he'll either enter it or it'll be assigned him. But probably it's better if he enters it, and then you can use that as this key here. Alternatively, you can also encrypt this, and a person will use the password to encrypt that. So you have password-based encrypt the encryption key, and then the encryption key can use to be viewed some of this. So what could be done is the very few people who need access to a certain number of rows here, say pick out, say, 5 customers. You use one key for 5 customers. Oops. And you have one guy who has access to that. Maybe you have 2 guys who have access to that. They'll each put in their password. Only they know their password. You take this key that you've encrypted that with, and you will encrypt it with each of theirs. And that'll be also some garbage that nobody can make heads or tails with, and it'll be useless to anybody for anything until it goes back the other way and it's decrypted. So if you did that to these 5 people's data, these 2 people would be the only ones who had access, and it would be through their passwords. Maybe it's 3 people. You can now give access to any DBA almost, and they can see there's rows, they can see there's numbers, they can see data that wasn't encrypted. Maybe you'll keep the zip code not unencrypted, right? Because who cares? So you'd see that maybe these 5 people were, they may be at the same zip code, but you could see that they were in there, and then there's the zip code, but you wouldn't know who they were. You wouldn't make heads or tails of it. So you could do that regionally, and it still wouldn't matter. But the DBA could see how many rows there were, how much data there was, the quantities of things, and et cetera, et cetera, et cetera. Maybe help searches. It'd be tough to do searches with that, but it can be done. Because these are still numbers, and you can always search numbers. The DBAs could get at it. Anybody who wrote software could see it without being compromising the confidentiality of it. Specific customer service reps would have access to it, and only that. You would only encrypt stuff they're supposed to see with their passwords, and so they'd only see that. They'd be assigned a few people. They'd see their data through however software would go into there, but they wouldn't see any others. And the other people, say if this guy has another different account would only see that guy's data. So we've solved the DBA issue. We've solved the service reps issue. And if you keep certain information, perhaps held in reserve, you don't have to encrypt everything. Only some important things, perhaps. You can still do some marketing analysis on it, and that'd be all right. Otherwise, you'd have to say decrypt it, but then you're kind of in trouble, and you defeat the purpose if you can decrypt it. But that's the way that should go. Some of the drawbacks are, of course, the number crunching is going to be really hard. So it won't necessarily be slow, but it will cause extra software, and it'll cause some machines to be bought. But in exchange, you get this really good security. And as a matter of fact, this is a legal level of security. Because the law is, you only see what you need to see. Nobody really needs to see that. Really only these two people. Maybe accountants or regulators, so you can add those on there too. Certainly not the NSA. And speaking of the NSA or the Secret Service or whatever, if this were a bank, there'd be some numbers involved here. And probably one thing you would encrypt is the numbers, and when something like a deposit went over $10,000, you'd report that, go through the process to report that, whatever. But let's see what else. So you do this double layer of encryption, basically, and these people could, they have the passwords to decrypt the keys that are only pertinent to them. A few other pertinent people will have their versions of it, and it'd still be in distinct rows too. Yeah. Just the fields, like the street, encrypt the street, or the town, or their first name, their last name, etc. But the database itself would still have the same structure. You just have to put in front of reading and writing to these pieces encryption. What else? Make sure to say everything. Well, I guess that's it. That's all I have about it for now. So the double encryption scheme, encrypt everything. You don't have to worry about redacting it when you extract it as an example, or to use as example, test data, whatever. In terms of searching, what those become is basically garbage numbers. If you wanted to search by, not sure you search by first name, but you can still search by first name. Say it becomes some number that's like 64 characters long still. You'd search it the same way, basically. When you made a list, so you can sort databases based on alphabetical or numerical. But when you made a list, so-called index of something like a name, you now have garbage, basically. Generally, these aren't the keys you'd want to change. You wouldn't want to change these very often. You'd change passwords, but you wouldn't want to change these. So that data is going to be fairly constant, and you will sort it just based on the new numbers that Won't change very much at all, because you really just won't change these. You'll have to keep them hidden away where they're just not going to be compromised, just like what you can do this for also, and I'm doing the secret key of the PKI, of the public key infrastructure. You have to keep that encrypted too. But you'll hide that away and hide these away really well too. And well, actually, you barely even keep it around. You keep it behind somebody else's password. But yeah, that's how you hide that too. That's password encrypted. This would be base encryption, and and you can organize it by do a mathematical search. What you can still use trees, or you can use a binary search just on a street of numbers. And there's even a further advancement of this double encryption. You have key 1, key at the lowest level, or the closest to the database of data. And like I said, you could have key 2, which I said could be a password. What if that weren't good enough? You didn't want one guy to have access immediately. So you wouldn't let anybody have this one. What you would do is let them have a part of it. For example, if you don't want to trust Biden to set off the nuclear weapons on a bad day, so he's pissed off. So you would give him one chunk. Then you give Abe Lincoln B, and then you give Austin Powers C. And then these guys would put in their own password. And they would encrypt those. And you'd have to add up their decryptions. Their password would have to decrypt this to recover this whole thing. And then that would be used to encrypt that, and then that would be used to encrypt that. So 3 layers basically. And the outermost layer would be multiple people having their own little chunk there. And that's how I do such things like that. Yeah. Good security, confidentiality on any data. And then, as I mentioned, you'd also want to segment it into databases that have different features. It's personal data. You'd use a lot more secrecy and a lot fewer DBAs, basically. Different and less DBAs for, say, personal data. And then with that, you'd use some cross-reference number. And that would be used here to access data here, say in what would you call ledger data, journal ledger data, where your transactions are all recorded. So it already doesn't look very good, but this scheme, multiple password scheme, you definitely have to do it on that one. And maybe this one is so obfuscated it's already so obscure that you're not going to see anything worthwhile anyway. But maybe not. You might still use it here. And then this could be the database for one state, and then this could be one for another, for a country. So you want to set it up like that. You probably have to do that. Big companies have to do that anyway. That's called sharding. Big companies have to do that anyway because they get too much data in one location. They need some data out in California. They need some in Reston, Virginia, etc. So add sharding, especially between very pertinent, personal identifiable information, we call it PII, and then that'll help give it some security, and then multiple layers of passwords. Guess that's all.